Hi, and welcome to the first video for lesson 5.3, day 2, solving trigonometric equations video. So again, these are your notes for the day, so please make sure that you copy them down on the handout at the door and turn them in to the blue box on the left for your daily grade. So let's get into it. Again, I figure we start off with the do first because that's what we usually do. So here we have find all the solutions to the equation 6 cosine of x is equal to 3 cosine of x plus the square root of 3 on the interval negative pi over 2 and pi over 2. Now, first off the bat, this sentence should make no sense to you because this says find all solutions on this interval. But we can say that it is all solutions on just the interval, right? It's not saying that we want all of the solutions. Like we talked a little bit about yesterday. But anyway, let's get into it. So our first thing we're going to want to do is the big strategy is to isolate your trig variable or get them all on one side of the equation. So here we're going to go ahead and do that. So we want to subtract 6 cosine of x, or 3 cosine of x. Okay, so what we now do, of course, is on the right side, those 3 cosine of x cancels, and on the left, we have 3 cosine of x is equal to the square root of 3 that gets brought down. Okay, so now we have 3 cosine of x is equal to the square root of 3. So again, we just want the cosine of x. We don't want anything else. So the 3 is multiplied by that cosine. So to undo that multiplication, we're going to divide by 3 on both sides. That'll cancel on the left. And that's going to give us that cosine of x is equal to the square root of 3 over 3. Now at this point, you might be telling yourself, well, I'm going to look on the unit circle and see what angle matches a cosine or an x-coordinate at the square root of 3 over the square root of 3. Well, the problem is there isn't one, right? So it's not always going to be the case that the cosine that you get is going to be equal to something on the unit circle. So one thing that we can do here to undo the cosine, of course, is to do the arc cosine of both sides. We didn't leave enough room here, but that's okay. I'll just kind of write it in there. So we need to take the arc cosine of both sides because an arc cosine is the inverse function of cosine. So those two will cancel out and we're just left with what's inside, which is x, which is what we want. And so on the right here, we notice we have arc cosine of the square root of 3 over the square root of 3. I'll rewrite that here. And so what you're going to need to use is a calculator, of course. Now, for that, you're going to want to hit second, the button second, and then you want to hit the button cosine because the second button of the cosine will give you the inverse. And then inside of that, you want to write the square root of 3 over 3, which it's going to look something like this, probably, when you write it out. Or into Nuka. So anyway, you do that with a arc cosine written around it, and what you end up getting is an angle of about 57.74 degrees. Of course, make sure that your calculator is in degree mode. You can do that by going to mode and then changing from degree to radian to degree, or if degree is already highlighted, you should already be good. So anyway, we have 57.74. Now here's the thing though, is that we want to find all the solutions on the interval negative pi over 2 to positive pi over 2. So the problem is that if you recall, cosine's range, or the numbers that it could spit out, the angles that it can spit out from putting something into it, are only up here, right? I can only get angles from about 0 to 180 degrees. But if you recall, well, if we're looking for the things that satisfy this interval, right, there's another cosine that should spit out a positive square root of 3 over square root of 3, and that's over here, right? Because if you recall, you can think of the analogy to the unit circle, right? Whenever you had the square root of 2 over the square root of 2, say like up here at 45 degrees, you knew that there was another square root of 2 over square root of 2 down here, but it really didn't matter that it was at negative 45. All you cared about was, well, what angle is going to give me square root of 2 over the square root of 2. Oh, 45 degrees, but below that negative 45 degrees would give me that too, so you had to put both. So the way we're going to fix that is, well, I noticed that if I go about 180 degrees over that, if I added 180 degrees, I can actually get to that other angle there. So we can get there and we can say, well, let's add 180 degrees. So that's going to be 4, 7, and that's 234. So that other angle all the way around will give you that 237.74. Okay, so let's talk about solving by factoring even more. Yeah, I know, we like factoring, I guess. So what we want to do here now is do a different type of factoring, something that you might have seen in, say, an Algebra 1 class or an Algebra 2 class. The only difference, of course, is that here we're going to be doing it with trigonometric functions, which is a bit different, and it functions slightly. We're going to have to remember something like a little bit of an extra piece, but you know, it should all work out in the end. And it works pretty much the same way. So here we're asked to find all the solutions on the interval from 0 to 2 pi to the equation cosine x plus cosine x minus 2 is equal to 0. Okay, so we want to find all the solutions to this. So let's write it out over here because I want to kind of make a point. So cosine squared of x plus cosine x minus 2 is equal to 0. So I want to draw the analogy, like I said, to Algebra 1 or 2, where, okay, we might have seen something similar, say, like this. Plus x minus 2 is equal to 0. Okay, so what we want to do here is, in this situation, is we want to think, okay, what two numbers multiply to get negative 2, and I'm going to write that negative 2 here, to get a 1 in front of this. So what two numbers are going to multiply to get negative 2 that get the 1 in front of the x there? Well, if I think about it, the only two numbers that can multiply to 2 are 2 and 1. But this 2 is negative, so one of these has to be negative. And if I think about it, well, picking which one is negative would make this 1? Well, that of course is just 1, because 2 minus 1 is 1. And so what these two numbers tell us right here is they tell us how to factor this. So that's x minus 1 and x plus 2. Again, remember, this is still 0 on the right. Now, the thing here is that, okay, well, there's two options for this equation. Either it's the case that this x minus 1 part has some x value so that this thing will equal 0, so then the whole thing would go to 0. Or the other option is that if I have x plus 2, that could also be equal to 0. And so then I would do my add 1 to both sides, subtract 2 from both sides, and that would be x is equal to negative 2. And so Algebra 1, that would be our answer, right? We'd be happy, we'd be done. Well, here in this trigonometric version of the problem, it's not as straightforward, but again, we can think about it in the same way. We want to choose to break this up so that this last number, negative 2, is the multiplied of two numbers that add to some number that's in front of our cosine x, which again is 1. Again, it works out the same, and again, works out the same. We know that that's 1 and 2, except this time, instead of writing x here, we're just going to write cosine of x, because that's what's kind of standing in for x there. That's remember, x is just something that's representing some number or some sort of symbol, and in this case, you can think of x as cosine of x. Minus 1 cosine of x plus 2 is equal to 0. Okay, so here at this point, now you want to say, okay, the same thing as over here. It could be the case that cosine of x minus 1 is equal to 0, or cosine of x plus 2 is equal to 0. Again, like in Algebra 1 or 2, we add 1 to both sides. Subtract 2 over here, That's going to give us that cosine of x is equal to 1, or cosine of x could be equal to -2. And this is where it starts differentiating from algebra 2. Because in algebra 2, we would stop, right? We would say, okay, we have. But here, we have our answers. But here, we actually have to think, okay, again, what angles would give us these values inside of these values to spit out of cosine? Well, clearly -2 is wrong, because there's no way we can get anything less than 1 or greater than 1 for cosine. Here for cosine x, though, there is some spots where the cosine is equal to 1. Look on your unit circle to figure that out, and you will see that the angle that we get +1 from, is going to be 0, or it could also be, well, again, it's in radians, or it could also be 2 pi. We'd have to go around the unit circle once to get that value of, on the x-coordinate, as our radian there. So our answers are 0 and 2 pi. And that's it. So again, the most of the problem is really very similar to what we've already done in algebra 1 or 2. The only difference is that we have to take this extra step of thinking about what angles would give us these trigonometric values, and also making sure that those trigonometric values could even make any sense at all. Okay, so let's go ahead and try another one like that one. So this is, again, same thing. Find all solutions to the equation sine squared x minus sine x plus 9 is equal to 11 on the interval -90 to +90. So the interval is different here. And also we notice that this function, or this equation, isn't right off the bat just equal to 0. We actually have 9 plus equals 11. So what we're going to actually have to do here is let's actually subtract 11 first, because we need this to be equal to 0 before we start anything. And that's really not going to change anything except for the fact that 9 minus 11. So now what we want to do is we want to go ahead and do the same thing we did in the last problem, which is turn it into the algebra problem. So again, -2 goes up here. Again, we notice this negative in front of sine, so what we have to do there is put -1 down there. And so what that's going to go ahead and do is say, okay, well, we know two numbers have to multiply to 2 and 1 in the top. 1 has to be negative because the -2 is negative, but they have to add to -1. So in this case, the -2 will actually go on the 2. So again, this splits up into sine of x plus 1, sine of x minus 2 is equal to 0. And we set both of those equal to 0. So we get that sine of x is equal to -1, and that sine of x is equal to +2. You just put them on the other side there. Now again, we run into that problem that no trigonometric function can be larger than 1 or less than -1. So that's fine. But sine is -1, so we're fine there. So where would sine of x be -1? Well, if we look at the interval, again, we're restricted here to values from 0, which is to 90 degrees, and to values that are 90 degrees negative. So where do we see sine as -1? Well, if you look on a unit circle, you might see it down here, right? You might see it down here, and that usually is listed as 270. But again, because we're restricted to -90 degrees, it's in the same place as 270. So instead of saying 270, we actually want to say -90 degrees there, because it is -90 is the same place, and it can only go to that place on the unit circle at -90. It can't go around because, again, we're restricted from -90 to +90 there. Okay, so what I'd like you to do now is let's go ahead and try number 3. So I think what you should do here is pause the video, maybe try it for 2 or 3 minutes, try to get through it, and then after that time has passed, after you thought about it, go ahead and start watching the video and we'll go through it together. Alright, so I'm assuming here that you've paused the video and gone through it a little bit. So what we're now going to do is do this with tangent. So I'm going to write it a bit over here because I think we ran out of room there, even though it kind of gives some nice space for that. graph to kind of illustrate things, but let's put it over here. So what we're going to want to do here first is recognize that Mr. Locke messed up and there should be a 2 in front of this tangent. So let's go ahead and fix that part. So yeah, there should be a 2 there, or else this is not really going to work out. So hopefully you fix the 2. So what we're going to now do is do the same thing we did. 3 goes here. Now notice we have a 2 in front of our tangent, so we have to put a 2 there. Any of you notice what I did there? Yeah. I wasn't supposed to do that yet. Why? Because the 2 is still there. What do we need? We need it equal to 0. See, even on video, I catch you in mistakes. It's like I'm a fortune teller or something. Anyway, so what's going to happen? I know there's a scribble here, but kind of just scratch it out there. So 2 minus 2 is 0. 3 minus 2 is 1. Tangent squared. X plus 2 tangent of x. Remember, we added that 2 at the beginning. So we want to now break this equation down because now it is equal to 0. So we put a 1 up there and a 2 up down there. And of course, we need 2 numbers that multiply to 1 but add to 2. That is 1 and 1. So that's going to break down into tangent plus 1, tangent plus 1, which is nice because setting either one of these equal to 0 is going to eventually get us that tangent is equal to -1. So what angle would make tangent -1? Well, that's a bit harder question than sine or cosine, but it's not out of reach. Because again, in our trigonometric part, we learned that tangent is y over x. So if y over x is 1, basically that means that both y and x are the same thing, right? Anything with the same thing over the same thing will always be 1. So we want to look for a place where y and x are the same, right? Where they're the exact same. Well, not quite the exact same, because there's negative. So we actually want to look for y and x where they are opposite signs. And so most of you might pick 45 degrees because that is where they're both equivalent. But the problem is that that's not quite correct because one of them has to be negative and one of them has to be positive. So what we want to do is we want to pick the angle x. So we're going to say x. The angle that we put inside tangent to make this equation true is going to be instead not pi over 4 but at 3 pi over 4 because that's one place where the signs are differ even though the numbers are the same. And of course the other place we're going to want to put it is 7 pi over 4 because again that's the 2 spots on that unit circle where the signs differ yet the 2 numbers are the same. Okay, so there's that one. Let's look at these word problems now. So now, as I mentioned in lecture, the trigonometric equations are very useful for word problems and have a lot of applications in the real world, right? In real world word problems. So let's do that. So we're going to say, let's read the problem. So the velocity of a particle moving along a horizontal line is given by the function vt is equal to 2 sine squared at t plus sine of t. Over the interval 0 to 2 and 2 pi, when will the velocity of the particle be equal to 0? Wow, that's a lot of stuff, isn't it? So what we want to do here is that vt is equal to 2 sine of t. I'm just writing the equation again. So one thing I want you guys to recognize is that this equation vt, you might be like, well, what in the world is that? Well, this again, v is just what velocity is. All this equation is saying is that velocity is a function of time, right? As something moves, when it has a speed, that speed occurs over a certain interval of time. So velocity or speed is a function of time. And that function, what turns speed, what relates the time that passes to velocity is this sinusoidal function. So this is some sort of sinusoidal something that periodically occurs. So the question is pretty straightforward, right? If this is velocity, when does the particle velocity be equal to 0? So we want to find the t, the time when this velocity is equal to 0. So mathematically, all the equation is saying is that set this equal to 0. Okay, what you hopefully have seen by now is that this really is just the factoring problems that we did yesterday. Because here we have a sine t, and here we have two sine t's multiplied by each other, hence the square. So if that's the case, I want to pull those out of the equation, and I want to say that 0 is equal to sine t in the front, because I pulled one out. And what's left over? Well, the 2 is there. There's a sign that didn't get pulled out, that's in front. And the sign of t here got pulled out completely, but you still have to put a 1 to indicate that something is there, right? And again, redistribute if you're ever confused, right? Sine t times 2 sine of t is 2 sine of t, 2 sine squared. Sine of t times 1 is just sine of t. So now that these two pieces are both equal to 0, we can then set them both equal to 0, because it's going to be the case that either sine of t is 0 or 2 sine of t plus 1 is equal to 0. Those are our two options, right, that would make this equation happen. So this one looks like sine's already done. It's already isolated. So here we want to actually subtract 1 from both sides, equals to -1. And then, of course, let's divide by 2. So we have sine of t is equal to -1/2. I'll put a little line there because I got a little close. So, again, we have to figure out just what we've been doing, which is what angles would make sine of t, what angle would make t equal to 0, and what angle would make t equal to -1/2. So if we look at the 0, 1, where would the y-coordinate on the unit circle be equal to 0? That happens at 0 and at pi. But we also have to remember sine of t is -1/2. So that's going to happen not at pi over 6, because y there is 1/2, positive 1/2. We want to find the place where it's -1/2, which the first place we look across the way, that should be 7 pi over 6. And then, of course, the other one is 11 pi over 6. And those are our 4 answers. So what this is basically saying is this particle, if it's moving along a horizontal line, from the interval, so over the time period of 0 to 2 pi, so about 0 to about 6 seconds. Didn't really give the time unit here. That was, I guess, bad physics, but you know, we're mathematicians. We don't worry about that stuff. Is over about 0 to 6 seconds. These are the periods in that point over those 2 seconds when the velocity of the particle, when it's just going to kind of stand still for a second and then continue moving. Okay? So let's try another one. All right. So now what we're going to say is, okay, we're going to say another type of word problem. And we have if f of x is equal to 2 sine of x, and g of x is equal to 2 sine of x, determine the x coordinates for all points of intersection of f of x and g of x on the interval -pi and positive pi. So we are given two functions here, and we're asked to find the x coordinates of all points of intersection. What in the world does that mean? Well, intersection typically means, if you think about a car or something, when 2 points, 2 cars meet, right? So at some intersection, right, we call that an intersection because the cars are meeting. Well, if we think about it with functions, if we're trying to find the x coordinates of the intersections, we want to find where they meet or where the two functions are equal. So all we have to do here mathematically is when it says intersection, we want to just set the two functions equal. So we'll say f of x, 2 cosine of x, 2 cosine sine of x, is equal to the other function, 2 sine of x. And that is mathematically what we've said. Now, at this point, hopefully you notice that this is just another factoring problem that we've already done, which is that, well, But first I need to get this on the left side. I need to get everything on one side in this case. That cancels. We get that that's equal to 0. And so again, remember, do not add cosine, sine, and sine. These two are two different things, right? Because this is cosine, sine. This is two trigonometric things multiplied by each other are not the same as one trigonometric thing. So we're going to say 2 cosine of x sine times sine of x minus 2 sine of x is equal to 0 on the right side. So what we now want to do is, of course, we notice there's some similar things. There's the 2 and the sine. So again, we want to factor those things out of the equation. So here, first of all, we want to pull 2 sine out of the whole darn thing. So again, those don't go away, they're just pulled in front, right? So I guess elimination would be a bad way to phrase that, but they're pulled in the front as 1 to this. And so what's left in the left side is cosine of x. Nothing is left, but that doesn't mean it's 0. We still need something there to indicate that something was there to hold it. So if I want to distribute it, I'll still get a 2 sine of x. And of course, that's equal to 0. And again, 2 sine of x, now we're at this pair where they're split up. So we make it 2 sine of x is equal to 0. And cosine x minus 1 is equal to 0. And we're off to the races, right? Because we've done this before. We've seen this before. It's nothing different. And 0 divided by 2 is 0. Cosine of x is 1. So again, it's very similar even to one we did yesterday, where the sine was 0 and the cosine of x was 1. Again, be careful because the interval is from negative pi to positive pi. So the first thing we want to say is, okay, well, that happens at x is equal to 0, right? In that circle. Oops, sorry about that. Well, I mean, you wouldn't feel that, but... so 0 radian. We could also go positive 180 degrees this way and get to this point where, again, it's not the case that the cosine would be 1. Actually, the cosine there is negative 1, but the sine is 0. The y-coordinate is 0. So we do want to include pi. But again, we could also get to that same point by going in that direction minus pi. So we also want to include negative pi because we could get there either going positive pi or negative pi. And so those are 3 ways that, again, what was our original question? The x-coordinates where these two functions intersect. Okay, so what I think I'm going to do here is go ahead and stop here because I think we've gone on long enough. This video is already getting to about 30 minutes and I want to give you all some time to fill out everything. Again, what I would encourage you to do, but hey, what do I know, is go through the rest of the notes and kind of confirm everything, make sure you understand, make sure you got everything perfectly, and then go ahead and still put this in the blue box. I'll only hold you accountable up to this point. We'll do the word problems tomorrow in class together. Alright, so it was good seeing you guys. I will talk to you tomorrow.